Good morning, students. So, in the yesterday's class, Madam has discussed about energy, energy stored in the capacitor, and a little bit of dielectrics. So, I'll continue with this dielectrics. As she told, so dielectric are the type of insulators which get polarize which get polarized when electric field is applied to them. The best example for this is A. They get polarized when the electric field is applied. Then what is this polarization? As she told, so polarization, if the such molecules are placed in the electric field in between the capacitor. So what happens here? The molecules, they get polarized. So negative charge of the molecule will be shifted this side, whereas the positive charges will get shifted in this way. The negative and positive charges shift in opposite direction. Negative and positive charges get shift in opposite direction. So this process, what we are seeing for the dielectrics. So this we say as polarization. So because of the polarization, the electric field in the conductor, it will get reduced. Electric field get reduced. How it is? So as Madam has discussed in the yesterday's class, it is E naught minus P by epsilon naught. Okay, where E naught is the initial electric field when a dielectric is not introduced. E is the electric field when a dielectric is introduced. And where P is polarization density. Polarization density. So electric field will get reduced by this amount. P is the polarization density and E naught is the initial electric field, and what is the present electric field when this dielectric is introduced, so that we get. So in this way, electric field, as soon as a dielectric is introduced between the electric field, between the capacitor, if you say, the electric field will get reduced. Okay. So now, when we say capacitance of the capacitor when dielectric is partially filled. When dielectric is partially filled, what happens to the capacitance of the capacitor? So in this, we have capacitor. This is positively charged. This is negatively charged. So I am introducing a dielectric. In between these two. T is the thickness of this. T is the thickness of this. D is the separation between the two capacitors. D is separation between two capacitors. T is the thickness and A is area of this plate. The two plates. Area of the two plates. Okay. So what it is? We have considered a capacitor of area A. Area of the capacitors, area of the each plate is A, separated by a distance D. Okay. So in that usually it is vacuum is present. In that we have introduced a dielectric of thickness T and dielectric constant K. Dielectric constant K is introduced. Okay. So before the introduction of the dielectric, the capacitance of before the introduction of the dielectric, capacitance is equal to, it is epsilon naught A by D. So this is initial capacitance when vacuum is present. When vacuum is present, C naught is equal to epsilon naught A by D. Okay, so this is our capacitance. How it is going to change now? With the introduction of the dielectric, how the capacitance is going to change. Okay. So for that, we'll find out. So what is the electric field here? Because by finding electric field, we are finding potential, so that we are substituting it in C is equal to Q by V. In that formula, we are going to substitute it. Because of that, what is the present electric field when the dielectric is introduced? So, electric field due to this dielectric. So, electric field due to dielectric. Because of the introduction of this dielectric of thickness T. So, what is the electric field now? So, definitely, as I mentioned, definitely this electric field get reduced. So, whereas here at these it will be same as how much it is? It is these distance if from D, if T is removed, how much it will be? D minus T, for a distance of D minus T. Electric field will be what it was before. So that itself it will be. Electric field due to the dielectric, if you take it as E. Dielectric of thickness T, is E. Whereas in the space, what it is for D minus T, electric field, other than dielectric. For thickness of D minus T, how much it is? It is E naught. It is E naught. For this, I have taken electric field E, whereas the remaining space what we have, for that we have taken it as E naught. So that the potential difference between these two plates, is equal to what it is? It is E into T plus E naught into D minus T. Because potential V is equal to, so we have electric field is equal to dV by dr. In the sense, dV is equal to E into dr. E into distance. Here the distance we are taking this thickness. E into T will give you potential difference across the capacitor. What is the potential difference across the capacitor? So when we connect a battery across this, an electric field will develop. When we connect a battery across this, electric field will develop. Positive charges will induce this side, negative charges will induce this side. An electric field will develop. In this, within the dielectric, what is the electric field developed? It is E. In this space, other than this dielectric, in this space, what is the electric field developed? It is, if I take as initially what it was, E naught, if we take E naught into D minus T. So therefore, what is the potential difference across these? This capacitor, it is E into T plus E naught into D minus T. So this is our expression for the potential difference. So then, what is this E? How it is changing? So we know that relationship between electric field, initial electric field, and electric field when the dielectric is introduced, and dielectric constant. While defining the dielectric constant, so we have E naught by E E is equal to K. Dielectric constant E is equal to. So E naught in the sense electric field. When vacuum is present, electric field. This is electric field when dielectric is introduced. So E naught by E is equal to K. So that I want the value of this E in terms of E naught. So what I can write? What I can write? E naught by E is equal to K. What I can write? I want value of E. E is equal to E naught by K. So this is E naught by K into T plus E naught into D minus T. E naught by K. So this E, since the dielectric is introduced for this thickness, so E naught by K into T plus E naught into D minus T. So this is our potential difference. So that now if E naught is taken common, what is left out inside? It is this T by K plus D minus T. T by K plus D minus T. So that V is equal to this V is equal to, it is E naught, so T by K plus D minus T. What I can write this E naught? E naught is equal to, shall I write it as sigma by epsilon naught? E naught is equal to sigma by epsilon naught. So if it is sigma by epsilon naught, E naught is equal to sigma by epsilon naught. What is this sigma? If Q is the charge on the plate, if Q is the charge on the plate, so sigma is Q by A. Sigma is Q by A into epsilon naught. Q by A into epsilon naught. So that if you substitute this value of E naught from here, so V is equal to Q by A into epsilon naught. It is this T by K plus D minus. This is expression for the potential difference between these two charges. Then what is our capacitance? From the definition of capacitance, so capacitance, so C is equal to, it is Q by V. C is equal to Q by V. So C is equal to Q divided by Q by A into epsilon naught. It is T by K plus D minus. Okay, so this Q and this Q get cancels. So C is equal to epsilon naught into A. Epsilon naught into A will go up. So it is D minus T, D minus T plus T by K. So this is our expression. So initially what it is, epsilon naught A by D. If no dielectric, nothing. If a dielectric of thickness T is introduced, what happens there? Dielectric of thickness T is introduced there. So that much area, that much thickness you are removing, and you are adding with a dielectric. Therefore, D minus T plus T by K. You are removing that thickness and adding this T by K. So how much air was present, that much you have. So since this dielectric introduced, so what is the area of thickness? Because of air, you are removing that and you are adding this D minus T plus T by K. If this T is equal to D, in a sense, dielectric is completely filled. Dielectric is completely filled. So during that time, if D is equal to, if D is equal to T, if it is completely filled, so during that time what happens? In place of T, you are substituting D. In place of T, you are substituting D there. In place of T, you are substituting D there. If it is so, so C is equal to epsilon naught A by D minus D plus it is D by A. So this D minus D get cancels. So capacitance is equal to that K will go up, K into epsilon naught A by D. If it is completely filled, the whole space what we have, if it is filled, so the capacitance increases by K times. It increases by K times. K times the initial in the sense when vacuum is present, then the capacitance increases by K times the initial capacitance when the vacuum is present. If it is completely filled. If it is partially filled, then also it increases by this value, it increases here. Okay. So this is the expression for capacitance of capacitor when dielectric is partially filled. So now we'll do one more similar expression. But here, instead of dielectric, if I take a conductor, when conductor is partially filled. When conductor is partially filled. Yes. So what it is? Exactly in the same way. Let the capacitor, let us consider a capacitor of initial capacitance C0. Let A be the area of the plates. A be the area of the plate separated by a distance D. Okay. So then we have initial capacitance is equal to epsilon naught A by D. So now it is a conductor. This is a conductor. What is a very important thing in the conductor? The electric field inside the conductor is zero. Electric field inside the conductor is zero. Electric field was something else. Here we got it as E naught by K when a dielectric is introduced. But here in the conductor, electric field is equal to zero. So when electric field due to conductor of thickness T, electric field is equal to zero here. Whereas other than this, whatever space is available, how much is available? D minus T is available. The electric field is E naught. That itself we are taking. So potential difference is now, it is E naught into D minus T. Just it is potential difference is equal to E naught into D minus T. So this is also will not be there. So this expression is also will not be there. So I write it is just E naught into D minus T. Same thing, E naught is equal to sigma by epsilon naught is equal to Q by epsilon naught. But only thing is this only we will have D minus T. D minus T. Capacitance is equal to C is equal to Q by V. So here once again just T by K will not be there. We will have D minus T. Q and Q get cancels. So this T by K not be there. Once again, here this will not be. Epsilon naught A by d minus t is your expression. Is your expression for the when a conductor is introduced. If this is our conductor, it is our conductor of thickness T is introduced, then this is the change. C is equal to epsilon naught A d minus T. Okay, so by what thickness conductor is there, that much electric field will not be there, that much capacitance will get reduced there. So because of that you are getting this expression. So similar special case when we see epsilon naught A d minus t, in a place of t you are substituting t, d minus t is equal to 0 here. D minus t is equal to 0 here. So that C becomes equal to infinity. In a place of t, if you substitute t, epsilon a by 0. In the sense, capacitance becomes infinity. Capacitance becomes infinity. What does it mean? If the conductor is completely filled, its capacitance is becoming infinity. What does it mean? So I have taken here this conductor is completely filled. Conductor is completely filled. What happens here if it is completely filled? This whole it is filled with a conductor. This whole it is filled with conductor. And this part you have grounded already. Whenever capacitor is there, the other end of it is, you should consider it as the other end of the other plate is grounded. If a whole thing is filled with a conductor, what happens? The charges starts to flow through this conductor. The charges which are here, the charges starts to flow this conductor and they enter into the earth, which can accept any amount of charges. You are continuously charging it. You are continuously charging this capacitor. These charges, what we have, these charges will flow to the ground. Continuously, we are charging here. We are charging by a cell. Continuously, we are charging. So these charges will flow to the ground. You are charging and continuously they will flow to the ground. In a sense, whatever the charge you give to this, it will absorb it. Whatever the charges you give to it, it will absorb it. So in this way, the capacitance of this capacitor becomes infinity. Whatever the charges you are giving, these will flow to this conductor and that will enter to the ground. So whatever charge you give to this capacitor, it will absorb it. So that is why, so this capacitor becomes an infinite, its capacitance becomes infinite. Because whatever the charge you give, they are flowing to the ground. If the conductor is completely filled between the two capacitors, so then what happens? So this capacitor becomes an infinite. Its capacitance becomes infinite. And if it is partially filled, this is our expression. If the capacitance is completely filled by a conductor, then its capacitance becomes infinite. So now you see effect of effect of dielectric. Effect of dielectric on different parameters. Different parameters. When a dielectric is introduced, so already we came to know what happens to the capacitance of the capacitor. So whereas for other parameters, like what happens to the charge, what happens to the potential difference, what happens to the electric field, and this energy, electrical potential energy, what happens to the electrical potential energy when this dielectric is introduced. So that also, what we are seeing, dielectric is introduced. One case we have taken when the battery is connected to it. When the battery is connected to it and when the battery is disconnected by it. One of the very important question for competitive exams. Dielectric is introduced. So with a battery with it, without battery, dielectric is introduced. One case we are seeing with battery, another case we are seeing without battery. What happens to the different parameters? So dielectric is introduced. So here we see when a battery is connected, when a battery is not connected, what happens? And these are different parameters. When battery is connected and when the battery is not connected, you are introducing the dielectric. In both the case, battery is connected here, battery is not connected here. What happens to the capacitance? First we will see. What happens to the capacitance? What is our formula for capacitance? C is equal to epsilon naught A by D. If dielectric is introduced, what happens? It increases by K times. K into epsilon naught A by D. K times epsilon naught A by D. So, whether it is a battery is connected or whether the battery is not connected, it does not, the capacitance of the capacitor does not change because it depends on the area, dimensions of it, it depends on area of it, it depends on the separation between the two conductors. On those factors it depends, not whether the battery is connected or not connected. So because of that, what happens there? Since you have introduced the dielectric, the capacitance of the capacitor increases by, so C is equal to, what happens here? C is equal to, it is K times C naught, because epsilon naught A by D, epsilon naught A by D is our initial capacitance before introduction of the dielectric. So this I have taken it as C naught. If this is C naught, C is equal to K times of C naught. Whether battery is connected to it or not connected to it, since the introduction of the dielectric has increased the capacitance, it does not depend whether the battery is connected or not connected. Therefore, here also it is C is equal to K times of C naught. Then what happens to the potential difference? What happens to the potential difference? V is equal to Q by C. What is happening? What happens to the C here when a dielectric is introduced? This C increases by K times. So as the capacitance is increased and battery is connected, so we can, capacitance of the capacitor has increased. So because of that, what happens? Even you can increase the number of charges that you are storing there, because its capacitance has increased. Its capacitance has increased by k times. So, if there is a chance, you can increase the charge on it. So, what happens to the charge here? V is equal to charge also increases by k times. And capacitance is also increased by k times, because capacitance is increasing by k. As soon as the dielectric is introduced, capacitance is increasing. As the capacitance is increasing, and since you are connected battery to it, you have the chance to store the more number of charges. How many more number? You can store k times of q naught you can store. So therefore, this k get cancels, q naught by c naught. So this potential remain constant. It remain constant. Potential difference remain constant. Dielectric is introduced and battery is connected there. As soon as the dielectric is introduced, capacitance is increasing. You have a chance to increase its charge, and since battery is connected to it, you can increase the charge by k times. So therefore, potential remain constant in this. When a battery is not connected, see what happens here. Capacitance is increasing k times. You have a chance to increase the charge, but battery is not connected there. Here, since battery is connected, you have increased the charge. Here, battery is not connected. Because of that, what happens? The potential V is equal to, so you are not storing any charges there because the battery is not connected. Charge will remain as Q, whereas capacitance becomes K times C naught. Charge will remain as Q naught. Here it has increased k times since battery is connected. Here there is a chance to increase as soon as dielectric is introduced, but we have disconnected the battery. Therefore, it will, though there is a chance, you are not introducing the charges. You are not storing the charges there. Therefore, Q naught by C naught. So what happens here? So this is our Q naught by C naught, means it is our initial potential difference. So this implies V is equal to, it is V naught by Q. In a sense, potential difference across the capacitor decreases by 1 by k times. Decreases by k times, V naught by k. Since battery is not connected there, if battery is connected, it remains constant. What was before, same thing. Here, battery is not connected, because of that, the potential difference decreases. So that's what we are seeing in the case of potential difference. Now, what happens to the charge? What happens to the charge? So here, charge. Capacitance has increased. Introduction of dielectric, capacitance has increased. There is a chance to increase the charge. You are increasing the charge. So therefore, it becomes K times of Q naught. Charge becomes K times of Q naught. Whereas here, the charge will remain as Q naught. There is a chance there, but battery is not connected. There is a chance, but battery is not connected. So therefore, it remains as Q naught. Whereas here, the charge is increasing by K times of Q. So what happens to the electric field? So E is equal to V by T. So what happens here? Electric field. What happens to the when a dielectric is introduced and a battery is connected? Potential difference remain constant. D you are not changing. D remains same. So V is remaining constant and D also same. So because of that, so what happens? E is equal to, if this is V naught by T, it remains same as V naught. It remains same as V naught because this is potential difference. K and K is getting cancelled. Because of that, it remains constant. V naught by electric field is equal to V naught by D. Electric field remain constant. In a sense, it remain as V naught. Though you introduce a dielectric and a battery is connected to it, electric field will remain as E naught. So here E is equal to V by D. So here it is V naught by K or divided by T. So this will be V naught by K. In the sense, this will be V naught by D. This is equal to E naught by. So what happens? When a battery is not connected, electric field decreases by K times. Energy, potential energy, electrostatic potential energy. Already in the yesterday class you have seen U is equal to 1 by 2 CV square. 1 by 2 CV square. What is here? U is equal to, what has happened to C? It is K times of C naught. K times of C naught. So then it remain as V naught only. Potential remain as V naught only, V naught square. So in fact half should be there. So here U is equal to half. of K into C naught. So U is equal to, it is, so this half C naught V naught square. So all this half C naught V naught square, all this becomes U naught. So this becomes K times of U naught. So this half C naught V naught square. This is nothing but your U naught it is. So it becomes K times of U naught. The potential energy. When a dielectric is introduced and a battery is connected to it, so it becomes K times of U naught. What happens here? U is equal to half K times of C naught. K times of C naught. And the potential here, it has decreased by V naught by K whole square. So this is equal to half K C naught. It is V naught square by K square. So this one of the K get cancels. So this is half. This is C naught. This is V naught square. So what it is? This is U naught by K. U is equal to U naught by K. Here it is U naught by K, whereas here K times of U naught. When a battery is connected, K times of U naught, whereas battery is not connected, it is U naught by K. So these are the parameters. What happens to the different parameters when dielectric is introduced there? So we have seen what happens to the capacitance, what happens to the charge, what happens to the potential difference, electric field, and potential energy. For all, we have seen this. So when next is when a distance between capacitor is decreased, distance between the capacitor is distance between the two plates is decreased, and the two things, it is decreased, battery is connected and battery is not connected. You are decreasing the distance between the two plates. One case is battery is connected, other case is battery is not connected, and what happens to the different parameters we will see. So first, capacitance. So we have C is equal to epsilon naught A by D. So what it is? When D is decreased, capacitance will increase. Capacitance is increasing, and there is a chance to increase its capacity. Capacitance is increasing. Whether you connect the battery or not connect, so it does not, capacitance does not depend on the battery. So what happens, it depends on the dimensions of it. Distance you are decreasing, capacitance you are increasing. So because of that, it increases here. And here also it increases because the battery is not going to change its capacitance. Its dimensions are going to change. Because of that, as soon as you decrease the distance, capacitance increases there. So here also it increases. Here also it increases. What happens to the charge? So here, capacitance has increased. There is a chance to store some more charges there. So battery is connected. You can store some more charges on it. So because of that, charge increases. Charge increases because capacitance has increased and there is a chance to increase the charge. Because of that, it increases. Whereas when a battery is not connected, there is a chance, since you are decreasing the distance, there is a chance. But since battery is not connected, you are not filling more charges in it. So therefore, it remains constant. It remains constant. What was before, with the decrease in the distance, of course, capacitance has increased, but there is no facility to fill the charge in it. Though we can do that, but battery is disconnected, so you cannot. So charge remains same. So what happens to the potential difference? Potential difference. So what it is? V is equal to Q by C. So charge is increasing. When battery is connected, as the distance is decreased, charge increases. Capacitance also increases. Charge is increasing. By what amount charge is increasing? By the same amount, capacitance also increases. So therefore, this remain constant. It remain constant. Getting now? By what amount charge is increasing, which is directly proportional to potential. By what amount charge is increasing, by the same amount capacitor. Q by C. So Q is remaining here. Q remains constant, whereas C is increasing. remains constant here. If I write Q remains constant, C is increasing. C increases means potential has to decrease. Potential difference has to decrease. Got it? So we have V is equal to Q by C. So Q is remaining constant, whereas C is increasing. As this is remaining constant, C is increasing. So because of that, V has to decrease. Now, electric field. What happens to the electric field? Q is equal to epsilon naught A. I can write it as electric field. Q by epsilon naught A. What happens here? Charge is increasing. Charge is increasing. So, even for this 2 epsilon naught A also you can use because epsilon naught A only. It is Q by epsilon naught A. Charge is increasing. Because of that, we are not changing area of it. So therefore, electric field also increases. Or even E is equal to V by D also. We can do this. Electric field. E is equal to V by D also. What has happened? V remain constant. D is decreasing. V remains constant either by this or we can use E is equal to V by D. What happens there? So for this potential difference remain constant. D what you are doing? You are decreasing D. So therefore electric field automatically increases. Either you can by this formula also you can or by this formula also you can do this. It increases. So whereas at this point what happens to the electric field? So E is equal to V by D. Distance you are decreasing, electric field increases by some amount. So whereas potential difference, electric field increases because as the distance you are decreasing, electric field increases. But since this is decreasing, these two are directly proportional, it decreases. So that the electric field remain constant. Got it now? Because of the decrease in the decrease between the two plates, distance between the two plates, what happens? Electric field is increasing. But as the potential difference you are decreasing, electric field decreases by same amount, so that the electric field remain constant there. Then lastly, potential energy 1 by 2 CV square. 1 by 2 CV square. So what happens here? Capacitance is increasing. Capacitance is increasing. Potential remain constant. V remains constant. Capacitance is increasing. So what happens? So here potential energy increases. Got it now? Potential difference remains constant, whereas C is increasing. So therefore, potential energy also increases there. So next, what happens when the battery is not connected there? So 1 by 2 CV square, U is equal to 1 by 2 CV square. Capacitance is increasing. This capacitance is increasing. What happens to the potential difference? It is decreasing. V square here. So therefore, this is just C, which is increasing. Here V square, it decreases. So therefore, the net amount here, it decreases. So when battery is not connected, the potential energy decreases there because it is V times, it is V square times, it is decreasing, whereas by just one power C, it is increasing. Because of that, the net potential energy decreases. So these are the what happens to the different parameters when the distance between the capacitor is decreased when the battery is connected and the battery is not connected. When dielectric is introduced, we have seen what happens to the different parameters and even distance between these two when it is decreased. During that time also we have seen. So these two are very, very important for a competitive exam point of view. Okay, we'll stop here. Thank you.